Hello students, welcome back to our course on theory of vibration and error elasticity. In today's session, we will discuss force vibration without damping. Is a fundamental concept that helps us to understand the resonance and system instability in engineering systems. Let us start by the understanding the problems in real world system. External forces acts continuously, like engineering vibration, wind loads, and aerodynamic forces. Unlike damping system, we have assume no energy loss. This makes the system ideal but also dangerous because energy keeps building up. So the learning objective is understand the force vibration due to the external forces, identifying the key parameter of this force vibration like frequency, amplitude, and natural frequency, comprehends resonance, the major problem in the system, related to real world application. So, what is a force vibration without damping? It is a vibration of a system subjected to an external periodic forces, but without any resistance to the motion. The governing equation is mx double dot plus kx is equal to f naught sine omega t. So here there is no damping term called Cx dot. The system response consists of two parts: natural vibration, force vibration, and the most important phenomena here is resonance. So the key concept of the equation is the equation of motion, that is mx double dot plus kx equal to f naught sine omega t. So this steady state amplitude vibration gives the equation shows the amplitude. It depends strongly on frequency ratio, also phase behavior. Like damping ratio is omega by omega n is less than 1 and equal to 1 and greater than 1. We call it as underdamped, overdamped, and critical damp. So here the frequency ratio is omega by omega n natural frequency with respect to the. Now the most critical condition resonance occurs when omega is equal to omega n. This point, the denominator becomes zero, and theoretically the amplitude becomes infinity. This means the system can experience very large vibration leading to failure. Unlike damping system, there is no mechanism to control this frequency or vibration code. Now coming to the based on the frequency ratio, we identify the three zones, which is amplification zones or amplitude increase the resonance is equal to 1, where the amplitude becomes extremely high. Attenuation zone amplitude decreases. Understanding this zone, which help us to engineering design in a safe manner. Coming to the real world application, looks real world application in bridges, wind can cause us oscillation. In machineries, the rotating imbalance creates a periodic forces. In buildings, earthquake includes vibration, especially in aerospace. The concept is directly linked to the flutter, which can destroy aircraft structures, also avoiding the resonance in a key design requirement. Next, coming to the first vibration concept map. The first vibration, the concept is mapped with parameters like mass, stiffness, applied force, and the frequency generator. This frequency is connected with the natural frequency omega n is equal to root of k by m, and this system frequency and natural frequency connected to the resonance that makes a response like steady state response or transient response maybe, or it may be a resonance. Now this can be modified by using a phase by changing a phase angle to 0 degree, 90 degree, and 180 degree, where r is less than 1 in the phase angle, or is equal to 1, that is, a frequency ratio equal to 1, or frequency ratio less than 1. So in phase, out phase, and the resonance. And coming to this three combination, we have formed the equation mx double dot plus kx equal to f naught sine omega t is the frequency equation for the forced free vibration. Now coming to the summary point, to summarize the first vibration without damping has no energy dissipation. Response depends on frequency ratio. Resonance causes theoretically infinite amplitude. This makes undamped system highly unstable. That's why damping is always included in a real system. So in this section, we'll connect this concept to the damper system and vibration control techniques. Thanks for the watching. Keep learning and stay curious. We'll see you in the next class. Thank you.